We also might have just stumbled upon the mother of all water reserves, floating in space. And it's been hiding under our noses for at least around 12 billion years. As for its size, it's hard to even imagine. 140 trillion times larger than all the oceans on our home planet combined. This cosmic water world is orbiting around a large black hole known as a quasar, located 12 billion light years away. Quasars feature supermassive black holes, spewing out colossal quantities of radiation. This one in particular is estimated to be 20 billion times heavier than our Sun, and carrying energy that could outshine 1,000 trillion of them. Here in our cozy Milky Way, we're used to seeing water in ice form. This water reserve in particular seems to be in the shape of vapors. The important thing about this discovery is that there may be water everywhere in the universe. We just need to learn where to look. You might be surprised to learn that not all stars are hot to the touch. We used to think all stars were like our Sun, these blazing hot balls of fire, ready to melt anything in their path. Their cooler counterparts are called brown dwarfs. What makes them special is that they're too small to pull off the nuclear fusion that keeps stars like our Sun shining. They don't give off much light or heat, which makes them hard to see. These brown dwarfs are also split into different categories. There's this one group called Y-type stars, and they're the coldest, with a surface temperature lower than your average cup of tea. If you could reach out and touch one, you'd probably just feel a cozy warmth. Around 4 billion years ago, Uranus apparently switched places with Neptune. It's hard to imagine planets that big doing that, but this theory might solve the mystery of how our solar system came to be. We know that rocky planets formed after big collisions. Take our planet for instance. Around 4.6 billion years ago, things kept bumping into each other around the Sun until our watery Earth reached its final form. It also included one larger collision that blew up enough rock and gas for it to generate our Moon. But when it comes to our larger solar system neighbors, Jupiter, Uranus, and Neptune, scientists still haven't got an answer. Standard models said it'd take forever for them to form, way longer than the solar system itself has been around. If this new theory is correct, it suggests that Uranus and Neptune came from this dense cloud of gas compacted around the Sun. Problem is, for the theory to make sense, they had to have swapped places at some point in history. Neptune is about 2.8 billion miles away, the farthest any planet can be in our solar system. Uranus is a bit closer, located at 1.9 billion miles. This new idea suggests that after they formed way closer to the Sun than they are today, their positions were altered. It could have either been because of many comets passing by over billions of years, slowly tugging the giant planets away. It's not a definitive answer to how gas giants were formed. It's more like a strong hunch backed up by looking at a lot of numbers. Speaking of weird things found in our universe, what about this floating spoon that NASA's Curiosity rover took a picture of on Mars? As the machine was cruising around the red planet, it stumbled upon this oddly spoon-shaped rock during the summer of 2015. The rock has a handle and even throws shade on the ground. It's not a leftover utensil from some Martian picnic, but rather what NASA scientists call a ventifact. That means it's a rock that got sculpted by the wind. It's not the first time the Martian surface has delighted us with weird, windy sculptures. There was the face on Mars, a rat, and even jelly donuts. It's also possible that diamonds are raining down on over 1,900 exoplanets out there in space. Scientists found out that you don't need particularly hot temperatures for carbon to turn into diamonds, like it was previously believed. Up until recently, we only knew of Neptune and Uranus to potentially feature sparkling showers. Astronomers were onto this interesting phenomenon for about 4 decades, but these planets were hard to study. We've only had one space mission, Voyager 2, swing by for a peek. A lot of progress is being made though, thanks to lab simulations. Neptune and Uranus are called the ice giants because their outer layers are filled with hydrogen, helium, water, and ammonia. what scientists call ice. And that gorgeous blue hue they have is due to the methane in their atmospheres. The beautiful diamondy phenomenon happens deep down, however. If we could visit, we would see that beneath the thick atmosphere, there are layers of very dense ice. And under all that pressure, chemical reactions are happening, possibly generating diamonds the size of a small town. We can't just dive into Neptune or Uranus with a diamond-seeking probe. Instead, the same conditions are being replicated in labs here on Earth, squeezing matter between diamond anvils and zapping it with lasers to mimic the extreme conditions. Under these circumstances, scientists managed to create artificial diamonds. Understanding how these rocks formed down there could also explain why Neptune is hotter than it should be, and why it's got such intense storms. These diamonds might also be the key to unlocking the mystery of Uranus and Neptune's weird magnetic fields. If we compare it to our planets, it doesn't behave the same way, so there may be weird things happening under the surface to affect the magnetism. NASA's plans include sending a new probe to Neptune or Uranus in the next decade. With the planets aligning just right in 2030, it's the perfect time to explore these potentially diamond-filled worlds up close. Planet Kepler 78b is another weird cosmic discovery. It's a hot, molten world that's doing laps around its star in record time, once every 8.5 hours, and pretty close, less than 1 million miles away. Hot environments aside, if we could set foot on its surface, we'd notice its sun being 80 times larger on its sky than the daily view we have here on Earth from our star. If we apply what we know so far about how planets form, this little guy shouldn't even be there. Specialists still don't have a clue how it came to be or how it ended up where it is now. What we do know is that it will disappear soon. Sort of. Since it's so close to its start, this scorching hot planet is going to collide with it in a couple of billion years. Sounds like a lot, but it's a cosmic jiffy. What's similar between our planet and Kepler 78b is the density. Sure, it's about 20% bigger than Earth and weighs almost double, but it's got that same solid interior. There's no possibility of it forming any closer to its star and simply moving away with time. It also couldn't have been born much further away and migrated in. Any movement inward would have been unstoppable, and it would have also collided with the star. This may not be a particularly groundbreaking discovery, but chances are you've never thought of it. There may be space dust in your hair right now. Every day, loads of outer space matter comes raining down on Earth. Sometimes we get flashy objects, like when a meteor turns into a meteorite by crashing down to the ground. But most of the time, it's quieter. This cosmic material drifts down through the atmosphere, landing softly as what we call space dust. It may not sound like much, but it does add up to around 14 tons every single day. This space dust contains tiny fragments of rock and metal, broken off from asteroids and comets during big collisions. These particles are very small. You can't see them without special tools. But every time you step outside, some of it might land in your hair.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the seventh planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the third largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one. And if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see. If you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset, though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover.
So, a planet a few times bigger than Earth, where actual diamonds fall from the sky like rain, it already sounds pretty sci-fi. But trust me, that's not even the strangest part of the story. You see, scientists recently pointed the James Webb Space Telescope toward this world with a name that looks like my driver's license, and found out that it ignores many rules. Most planets, just like Earth, circle normal stars like our Sun. But the Diamond planet, let's call it like that, circles a pulsar. This world circles something far scarier than a normal star, a pulsar, a type of neutron star. Pulsars are born when the massive star collapses and a supernova goes boom and wipes out all nearby planets. And even if those planets don't stop existing immediately, radiation literally strips material off of the companion star over time. Bit by bit, the pulsar eats it alive, like a cosmic cannibalism. But the new mysterious object isn't a star, it's a planet. And planets shouldn't survive anywhere near that kind of radiation or evolve into something chemically bizarre. But anyway, the pulsar that the Diamond planet lives next to spins insanely fast and fires beams of radiation like a cosmic lighthouse made of gamma rays. Normally, stars blind telescopes when scientists try to study nearby planets, but pulsars don't shine much in the infrared light, the kind the James Webb Space Telescope detects. So, astronomers could see the planet glowing while its deadly parent, the pulsar, stayed almost invisible. They noticed that its mass, radius, and temperature are pretty normal for a so-called hot Jupiter. That's one of the rarest types of exoplanets. But then, things got weird. Well, weirder. First off, not so many pulsars we know of host exoplanets. And none of those planets scientists have spotted so far are gas giants. Second, the diamond planet's shape is pretty weird. Because it orbits its pulsar at a distance of just around 1 million miles, it's really affected by its gravity, and that's why it has its unusual lemon-like shape. But the weirdest thing is the planet's atmosphere, which contains huge amounts of helium and carbon molecules. That carbon is floating freely instead of bonding with oxygen or nitrogen, like it usually does. Under temperatures between about 1200 and 3700 degrees Fahrenheit, carbon shouldn't survive in that form at all. On almost every other world astrophysicists know of, it quickly links with other elements. But our weird planet just ignores that rule completely, and none of the well-studied exoplanets act like this. It looks like the pressure deep inside this diamond world squeezes carbon so hard that it turns into diamonds, and they constantly fall toward the core like glittering hailstones the size of mountains. Scientists still don't fully understand what's happening with this diamond world. They tried comparing it to something called a black widow system. It usually has to do with two objects locked in orbit, a dense pulsar and a smaller companion star, similar to our Sun but much brighter. The diamond planet shows overwhelming amounts of carbon, far more than physics tells us is possible. It doesn't look like it formed like a normal planet from leftover dust and gas, and it doesn't seem like it formed from a star that got stripped down by a pulsar. So, as of now, it doesn't fit into any known formation scenarios. The pulsar may have erased a former companion star so completely that only an ultra-dense carbon core survived. Another idea is that extreme radiation reshaped an existing planet over millions or billions of years. Meanwhile, while scientists are solving this mystery, let's visit Uranus, where it also rains diamonds. Deep inside this ice giant, temperatures climb above 12,000 degrees Fahrenheit according to mathematical models, and pressure rises millions of times higher than Earth's atmosphere. Methane gets crushed until its molecules snap apart. The freed carbon atoms cling together, form crystal structures, and grow into diamonds. Those diamonds sink deeper, melt in hotter layers, rise again, and repeat the cycle endlessly. And not only that, the James Webb Telescope showed that Uranus's magnetic field tilts about 60 degrees off balance, which means the planet's invisible magnetic shield sits crooked compared to its rotation. On Earth, auroras stay near the poles, but Uranus spreads glowing auroras across huge regions of its atmosphere. Webb watched the planet spin for 15 hours, which is almost a full Uranian day, and captured massive energy flows moving through the upper atmosphere like glowing weather systems powered from deep inside the planet itself. All this means that ice giants distribute heat in ways we barely understand. Uranus almost rolls sideways as it orbits the Sun, and that strange orientation seems to twist how charged particles move through its atmosphere. Instead of neat polar light shows like ours, Uranus creates wandering auroras, also pronounced wandering auroras, that stretch across the planet like cosmic neon storms. Studying them can help researchers understand magnetic fields. It's a pretty big deal because they act like planetary force fields that protect atmospheres from space radiation. At the same time, another mysterious world has its own pretty weird weather system. I'm talking about Titan, Saturn's largest moon. Titan doesn't use water for rain or lakes. It uses methane, the same gas we burn for fuel on Earth. Scientists discovered that Titan's seas actually shape its local weather, just like the Great Lakes influence climates in North America. Liquid methane evaporates, rises, cools, and falls again as mist or rain. Warm air lifts upwards, while cool air rushes in behind it and forms convection cells, which are giant looping currents of moving air that drive storms. And not just regular storms we're used to. No! Titan has lake breezes, fog banks, and seasonal weather cycles that run on hydrocarbons instead of water. Titan's big brother, Saturn, doesn't just have weather. It throws atmospheric tantrums on a scale that makes Earth storms look like brief summer rain. When NASA's Cassini spacecraft orbited Saturn between 2004 and 2017, its instruments picked up lightning flashes so powerful they could shine even in broad daylight. On Earth, lightning already releases temperatures hotter than the surface of the Sun for a split second. On Saturn, some bolts carry 10,000 times more power than lightning here. Cassini even detected radio signals from these storms, which means researchers could literally listen to thunder rolling across another world. Some of these storms expand more than 190,000 miles wide, large enough to circle nearly the entire planet. Then there's Saturn's famous North Pole hexagon, a perfectly shaped six-sided jet stream spinning non-stop for at least 40 years since spacecraft first noticed it. Wind streams racing around the pole naturally lock into this geometric pattern. That hexagon stretches hundreds of miles deep into Saturn's atmosphere. Now let's hop onto Venus, where the climate spirals completely out of control. At its south pole, a spacecraft saw a massive double-eyed vortex, roughly the size of Europe, spinning endlessly in thick yellow clouds. Unlike Earth, where the atmosphere mostly moves together with the planet, Venus has something called superrotation. Its atmosphere races around the planet about 60 times faster than the surface below. Winds roar at speeds near 250 miles per hour. The surface temperature there is around 870 degrees Fahrenheit, hot enough to melt lead, zinc, and many spacecraft components. It's so hot because sunlight enters easily, but dense carbon dioxide traps outgoing heat so efficiently that cooling never happens. Even rain behaves cruelly there. Sulfuric acid forms high in the clouds and falls downward, but intense heat evaporates the droplets before they ever reach the ground, and rain just disappears mid-air. Well, our final stop of the day is Neptune. It receives only a tiny fraction of the sunlight Earth gets, but somehow drives jet streams exceeding 1,300 miles per hour, twice faster than the speed of sound. Heat must be rising from its interior to fuel such speeds. When Voyager 2 flew past in 1989, it spotted the Great Dark Spot, a storm system roughly the size of Earth itself. Neptune's storms appear and disappear within years, and behave like living systems that constantly evolve. Some of its storms drift toward the equator and then suddenly reverse direction. That never happens on Earth. So Neptune is another reminder that weather in space doesn't always follow familiar rules. Sometimes, physics builds systems so extreme that scientists can't explain them even after decades of observation.
Ah, well-deserved vacay, finally. This time you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus Moon's oceans, let's talk about Uranus itself first. The seventh planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have, friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet. And that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups: 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon. and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my. These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too. And because of that tilt, they have crazy seasonal cycles just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky, or icy, or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half-ice/half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These 2 shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces, and the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as an antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited. These oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's fifth biggest moon, Miranda, welp, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe, UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore.
Beneath the frozen surface of Uranus's moon, Ariel, something massive may be hiding, an ocean more than 100 miles deep. That's 40 times deeper than the Pacific Ocean, and it's been sealed up under ice for billions of years, waiting to be discovered. So Uranus is this pale blue gas giant way out there, the loner planet that never gets much attention. But recently, scientists turned their telescopes and computer models toward one of Uranus's 29 known moons, Ariel. Compared to its sisters and brothers, Ariel's got quite a unique personality. When the Voyager 2 spacecraft flew by in 1986, it caught some photos showing an oddly smooth surface peppered with craters, fractures, and valleys. Those details might not sound exciting until you realize what they mean. This moon was geologically active, moving, cracking, and reshaping itself like Earth does. That's rare in the outer solar system, where most moons are just frozen popsicles, quietly spinning around their planet. When scientists studied those fractures, technically called grabens, they found something strange. The pattern of these cracks looks exactly like what happens when there's pressure building underneath the surface, like a balloon stretching before it pops. It's as if something deep inside Ariel was pushing outward, warping, and breaking the crust. The most logical culprit would be a subsurface ocean, which was once warm enough to push against the icy layers above it. An ocean sealed under miles of ice, hidden for billions of years. So, how would something so far from the Sun even have liquid water? Well, Ariel's orbit isn't perfectly circular, but slightly oval, which scientists call eccentric. That means as it circles Uranus, the gravitational pull changes a little each time. The constant tugging stretches and fluxes the moon's interior, creates friction, and voila, generates heat. Combine that with natural radioactive decay inside the rocky core, and suddenly you've got enough warmth to melt ice deep below the surface. So Ariel might have been making its own geothermal spa out there in the middle of nowhere. Scientists modeled its interior structure and found that the stress the tidal forces were causing could have kept liquid water stable for millions, maybe even billions of years. Even cooler, or warmer in this case, is that traces of that ocean may still exist. Ariel's icy shell shows features that look recent, geologically speaking. That means the moon hasn't been completely frozen for all eternity. Beneath those fractures, there could still be small pockets or thin layers of liquid water. And this brings up the most exciting part. Water means potential life. Every time scientists find signs of liquid water somewhere in the solar system, they start whispering that question we all secretly love. Could something live there? Sure, Ariel's no tropical resort, but remember, on Earth, we've found microbes thriving near hydrothermal vents at the bottom of our oceans, living off chemicals, not sunlight. If Ariel once had similar vents pumping heat and minerals into its ocean, it could have easily hosted its own microscopic residence. And if there was an ocean there once, it could still have salt in its interior. Scientists believe salts and ammonia could act like antifreeze, keeping the water liquid longer. So even though the surface temperatures drop to minus 351 degrees Fahrenheit, the inside could stay cozy enough for water to remain unfrozen. Now, before you start packing for Uranus, let's remember this is a moon orbiting a gas giant that's about 1.8 billion miles away from us. Visiting it isn't as simple as booking a plane ticket. Voyager 2 is the only spacecraft that's ever gotten even close, and that was almost 40 years ago. We have better photos of Mars's sand dunes than we do of most Uranian moons. So, for now, scientists rely on clever modeling, telescope data, and a lot of patience. Still, this discovery is big. For decades, we've looked at moons like Jupiter's Europa or Saturn's Enceladus as the best representatives of the ocean world category. They're icy, they have subsurface oceans, and scientists have actually detected water plumes jetting into space from them. But now Ariel joins the club. If we ever send another mission to Uranus, Ariel would be a prime target for exploration. Now, another destination worth checking out is Saturn's moon, Mimas. Scientists have always thought it was just a frozen rock ball, but it might be hiding a whole ocean underneath its surface, and a future spacecraft could find it. Researchers have been mapping how thick the moon's icy crust is, and those maps help them figure out how old this ocean could be and where the ice is thinnest. That's the jackpot spot for future missions to check for liquid water. Mimas doesn't look like a typical ocean world. When you look at Europa or Enceladus, you can literally see the cracks and crevices in their icy shells. Mimas looks smooth and quiet, almost like a cue ball in space. The craters look permanent, carved in rock rather than ice. Nothing about it screams ocean world. But a few years ago, data from NASA's Cassini spacecraft started telling us otherwise. Cassini, the probe that gave us our best tour of Saturn and its moons, kept sending back info that didn't quite make sense unless Mimas had liquid water under all that ice. The more Cassini's data rolled in, the more it looked like there might be a newborn ocean hiding under 12 to 19 miles of solid ice. Scientists used models originally made for Europa to figure out how heat moves through Mimas's icy shell. They wanted to know how thick it was, how much heat it could trap, and whether it could melt ice below. And they found that once melting starts on Mimas, it doesn't stop. It accelerates, and really quickly. All that melting ties back to Mimas's orbit. The moon doesn't orbit Saturn in a perfect circle. Its path gets a little stretched. That oval shape means the moon gets pulled and squeezed by Saturn's gravity as it orbits. The same way the moon's gravity gives us tides here on Earth, Saturn's gravity tugs on Mimas. But instead of water tides, it's flexing solid ice. And that flexing creates heat. So, at some point, something kicked Mimas into a slightly weirder orbit, maybe a collision or a gravitational nudge from another moon. The inside of Mimas heated up, melted some of its ice, and created an ocean under the surface. But then, gravity slowly started to pull Mimas's orbit back into a circle again. When it does that, the heating will stop, and eventually, the ocean will freeze all over again. So basically, Mimas is in its warm ocean-having phase right now. Computer models show that the orbital change probably happened just 10 to 15 million years ago. That's nothing in space-time. It also turned out that the heat on Mimas doesn't move in a simple straight line. It kind of loops and twists, depending on how thick the ice is, which means finding this ocean won't be easy, but it's not impossible. Studying possible ocean worlds, and the ones of which we already know for sure, like Europa, Enceladus, Titan, and Callisto, is crucially important for us down here on Earth. Every time humans find liquid water somewhere new, we're basically discovering another version of the one thing that made us possible. Earth's oceans gave birth to everything alive, including us humans. When scientists learn how Europa's or Enceladus's oceans stay liquid without sunlight, they learn something about Earth's deep sea vents, about heat and balance. When they model Titan's chemistry, they're basically looking at what Earth might have been like before life began. So maybe life isn't that rare, and one day a probe will dip into the icy ocean of Europa with NASA's Europa Clipper, or scoop up water from Enceladus's geysers and find something, even a single living cell. And when that happens, it'll rewrite everything we think we know about life. It'll also remind us we're not the center of the story, but just one chapter in a universe full of water. Now, I'll bet you remember the furthest planet from the Sun is Neptune. When European astronomers argued about what to call the newly discovered eighth planet back in 1846, they settled on the name of the Roman deity of the sea. This ice giant is 4 times the size of Earth. And if our planet was the size of a nickel, Neptune would be as large as a baseball. At the same time, the ice giant is 17 times as heavy. If you were approaching this icy world, it would seem blue and perhaps inviting. But this blue surface is actually a layer of swirling gas and permanent clouds. So don't get your hopes up. You wouldn't be able to land on this planet. Its mantle, made up of water, ammonium, and methane ice, is the closest thing Neptune has to a surface. But even down there isn't solid ground for you to walk on. Anyway, this distant planet is surrounded by mystery, and astronomers haven't cracked all of it yet. Why are the winds on Neptune so fast? Why does this world shed more heat than it gets? Why is its magnetic field offset? And what is the Great Dark Spot? Well, let's try to find some answers. Neptune is around 30 times as far from the Sun as our home planet. That explains why studying this distant world is so difficult. It also means that the planet gets way less light and heat from our star. But at the same time, Neptune radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers don't know for sure why it happens yet, but of course there are theories because they're scientists. Some experts believe there is something fierce inside the blue planet that causes it to generate more heat than it receives. It might be the reason for Neptune's huge differences in temperatures, from minus 260 degrees Fahrenheit at the planet's rigid cloud tops to more than 12,000 degrees at the core of the ice giant. So you're going to want to dress in layers. Now, such temperature variations might be the reason for powerful windstorms. Their speed can reach 1,200 miles per hour. For comparison, the most powerful winds on Earth move at a speed of 250 miles per hour. Another curious thing about Neptune's winds is that they are blowing westward, which is backward to the rotation of the planet. A study published in 2013 supposed that the winds on Neptune would appear in thin layers no more than 600 miles thick. Such a shallow depth might mean that condensing and evaporating moisture could produce those crazily fast air currents. Then there's the issue of Neptune's magnetic field being offset. If you were to overlay a magnet on this planet, it wouldn't line up with the center. Astronomers aren't sure why it happens. Magnetic fields are produced by moving currents, and all the planets, including Earth, are believed to have some conductive material moving in their bellies. But with Neptune's belly, it's a bit different. Its magnetic field is tilted at 47 degrees to the planet's rotation, which means that the rotation and magnetism aren't aligned inherently. And don't forget about the Great Dark Spot. No, I'm not talking about the most massive storm in the solar system. That one is called the Great Red Spot and is located on Jupiter. I mean a corresponding spot on Neptune discovered by Voyager 2 in 1989. In 1995, the Hubble Space Telescope turned its eye on Neptune. But, disappointingly, by that time, the spot had already mysteriously vanished, and scientists have no idea how exactly it disappeared. But guess what? Another dark spot has been found on the ice giant. Astronomers have known for quite some time that, from time to time, Neptune's surface gets dotted with such spots. These bizarre discolorations have been linked to high-pressure areas, coming and going over the course of a few years. But no one has seen a dark spot forming until recently. Since then, astronomers have been observing the birth of dark spots quite regularly. Now they have a much better idea of where and when these huge vortices might form. Now, despite assumptions, astronomers once thought Neptune was a boring, featureless world, the ice giant has a hyperactive atmosphere. It's turbulent, with cloud ripples and severe storms. Plus, this planet has a ring system. Disappointingly, those rings are not distinct hula hoops circling Neptune, like those of Saturn. The ice giant's rings are weirdly chunky and contain gobs of material that form arcs in the outer ring. Astronomers explain that these clumps are actually places where loads of ring particles are stuck together. What it means is still unclear. But my favorite thing about Neptune is this one. Astronomers believe that deep inside the planet, there might be a layer where it rains diamond crystals. Intense pressure and temperature inside Neptune break methane molecules apart, releasing carbon. These carbon compounds find their fellow molecules and create long chains, which then get squeezed together, forming beautiful crystalline patterns like diamonds. When these diamond formations drop through the layers of Neptune's mantle, it gets too hot for them. That's why they vaporize, float back, and, you guessed it, repeat the cycle. Now you know why it's called diamond rain. How about a fun little experiment? Let's say we exploded Neptune, in the name of science, of course. As you already know, this planet doesn't have a solid surface. That's why, after activating the process, you'd see Neptune's liquid mantle burst. It would look like a water-filled balloon thrown down from the 50th floor. Disclaimer, don't do this at home. The impact would send splashes of water, ammonia, and methane ice away into space. It'd be followed by lava-like remains of the planet's mantle, liquid and red-hot. And then there would be a hurricane of solid rocks. That's what would be left from Neptune's solid core made up of iron and other metals. Okay, let's put this pretty ice giant back together. I've got one more experiment for you. Let's replace the Moon, yes, our good old satellite, with Neptune. The ice giant is definitely way larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, and we would see it not only at night but also during the day. It would appear to be 15 times larger than the Sun. If everything else remained the same, solar eclipses would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. And since Neptune is also much more massive than Earth, its gravitational pull is much stronger. That's why, instead of getting itself a powerful companion and protector, our planet would end up as a satellite. Yep, Neptune's moon. It would orbit Neptune slightly further than its own largest moon, Triton, and there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with any of Neptune's satellites. Even so, we would have more than enough problems. Tides on our planet would be 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. Like we need more of that, huh? The seismic activity would increase, setting off earthquakes and volcanic eruptions. Well, that sounds unsettling. So let Neptune remain where it is now. I'm okay with a good old moon. Now we're done with the experiments, but hear me out. Beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding another big planet from our sight. Are they in cahoots? This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not.